Today we are going to solve minimum size subarray subproblem. As per the definition, we are given one positive integer array, one positive integer s, and we need to find out the minimal length of a contiguous subarray. There could be more than one contiguous subarray which would be having sum greater than or equal to given integer s, but we need to find out the minimal out of them. Although it is given contiguous subarray, but as per the definition, subarray is always contiguous. If it is not, then it is called a subsequence. So what is the very first intuition which comes to our mind? What is the easiest solution which we could apply in order to find out the solution? Well, what we can do, we can find out all the subarrays possible for this particular array, and then we try to find out which one of them are having a sum greater than or equal to s, the given integer, and then out of them we can try to find out the minimal. Minimal here means that there could be possible more than one subarrays with same size and same condition fulfillment. In order to generate the output for this particular situation, we would choose any of them. But for this particular solution, which is the easiest one, we need to find out the time complexity. And the time complexity for this would be n square, because we know the total number of subarrays possible would be n into n plus 1 divided by 2. That we know with our elementary mathematics. If you are thinking about that total number of subarrays would be 2 to the power n, then you're wrong, because that would be total number of subsequences possible. So in this case, n square solution would be our time complexity. Can we do better? Yes, we can do. We can definitely find out the solution in ON time complexity, that is linear time complexity, with the help of sliding window approach. But before jumping to the solution, you need to learn about the sliding window approach. To do that, you need to keep watching the video and do not forget to subscribe to our channel. Your support keeps us going. So keep watching the video to learn the solution. Great. Let's discuss what is sliding window approach. So we have two parts, one is sliding and another is window. What does it mean to have a window? A window means we have a bounded structure. So there will be a left index and then there will be a right index, and the bounded structure will be called the window. Then what does it mean to have a sliding? Sliding means that the window will be sliding. It will be shrinking from left side, it will be growing towards the right side. To slide, what we will do, we will move the left index plus plus, and to grow we will do right index plus plus. So this is how our window rolls. Let's say you have an array, then in the array you have a bounded structure which is your window of a given size. So let's say size is 4. Once the growing phase completes, then we will be shrinking from the left side moving to the right, shrinking from the left side moving to the right, and this is how the sliding window slides. So we have two parts in our sliding window approach. One is the growing phase and another is the sliding. Hope I was able to make you understand this particular approach.
समझ रहे हो समझ रहे हो आप समझ रहे हो ना बस यही है.
Now let's jump to the implementation of sliding window approach for this particular problem. We will have a left index, the left boundary, and the right index as the right boundary. We also will be having a variable to keep the total sum of of the elements which we have seen so far in our window. And also we will be keeping count of what is the minimum size subarray we have seen which is fulfilling the condition. And because we are taking minimum here, we will initialize it with integer.max value. While we are going over the array, we will include the element into total sum so far. We will check if the total sum so far is fulfilling our condition, which is if the sum is greater than or equal to s. Then we will mark the minimum size of current structure. We will be taking the total size as right index minus left index plus 1. That would give us total number of elements present in the array. We will be either updating or putting the value in minimum size so far for the very first time. And then we will shrink from the left side. To shrink from the left side, first we will reduce the element which is present at the left boundary from the total sum so far, and then we will shrink with the help of left index plus plus the left boundary. We need to maintain the order of these two statements, else the algo won't work properly, because if we shrink first and then we reduce, then we might be reducing the wrong element out of the total sum seen so far. At the end, we would return the minimum size so far, which is keeping the total size which is minimal and fulfilling the condition. But we also need to check for the edge case possible. The edge case is that either the total array which is present is having a length 0, or it is also possible that the total sum of all the elements together is not going over s or becoming equal to s. In both the cases, we need to return 0 as per the problem statement. So to do that, what we will do at the end, we will check if the minimum size so far is still having a value of integer.max, then we would return 0, else we would return the updated value of minimal size so far. We also made a very small mistake of having an if loop which is checking for total sum so far greater than or equal to s. It is possible that the element which is including at the right boundary is so big that it's not possible for just one decrement to reduce the value lesser than s for the total sum so far. Hence we do a while loop instead of an if loop. And this worked really well. I hope I was able to make you understand. Now let's try to analyze the time complexity of sliding window approach. In the case, what we are seeing is that although we are having a for loop and then inside a for loop we are having a while loop, that might give you an impression that the total complexity might not be linear. But if we look very closely, we will find out that eventually total number of loops which we would be carrying out will always go till n. Hence, our time complexity will always be linear and nothing more than that. I hope this video helped you learn about sliding window approach. If that is the case, and if you like the video, do not forget to subscribe to our channel. We need your support to grow and bring more such videos for your betterment. Thank you.